Now the columns across the top, we need a number of indicators. The first indicator is noise. So the first column should be noise. The next column is temperature. Tomorrow, if we have the pollution sensors, the next column will be pollution, but we can't do that today. Column after that is smell. And the column after that is fear of crime. So let's start with noise. Who's got a noise meter app on their phone? Whip it out and give us a noise reading. $52. Anyone for any more?
50, 60, yeah,
64, 60. Guys over here? 64. I'm getting somewhere between 57 and 65 on this. This is more accurate than what you've got, but it's slower. It's a slower response time. What's the problem with measuring noise with something like this?
That whenever we're talking, the noise is higher.
That's the first important point. Is noise consistent in an urban landscape? So we had the guy pushing the trolley past. That was really very noisy. If we're stood by the road and a car doesn't go past, it's going to be much quieter than when a car does go past. So, when I say write down what noise it is at location 1, it's a snapshot. It's a moment in time. So, I would be writing down 56.6. But that's with the background noise of the truck going past. It's with, without me talking, without things flying overhead and so on. There's lots of ifs and buts in that. Now, if you were doing this properly, you would take a measurement over, say, a minute, and you would average it. And you'd say, okay, that's a snapshot for this minute. And that would remove a lot of spikes. What about time of day? Does that make a difference? How? So if you're walking around a busy urban area, at rush hour, you're going to have a lot more traffic noise than you are at other times of day. You're going to have people, messing around and shouting in the street in the way that they might not at 3 in the morning. So again, you're only capturing a snapshot, and it's a snapshot dependent on the time of day and the conditions. So if it's a Monday versus it's a Sunday, for example. So we've all written down, hopefully, a noise measurement for location 1. What is our next environmental indicator? So, those who have the temperature video cameras, get into your groups. If you're in the Wednesday seminar group, join one of the other groups. Turn the power on and open the lens. This is your first test of intelligence. There's a switch on the bottom on the front, just underneath the lens, as if by magic. Has everyone got a thermal image? Colin, why don't you zoom in on one of these thermal images? Okay, so has everyone had a chance to have a look at what it looks like when you look through one of these things? Okay, Okay, so straight off the bat, you can see that people's noses and cheeks can tend to be of different temperatures, but buildings tend to be of different temperatures as well. So what we're going to look at, essentially, is, it's really weird being filmed with a thermal imaging camera. What we're going to look at is how well insulated different buildings are. So one of our measures in the environment that we go around is the stock of building in good condition. So if you're not getting a big temperature offset, if you're not getting lots of heat being pumped out by a building, you can hypothesize either that the heating's off or that the heating is well insulated. So let's have a look at biosciences. Now look at the difference in temperature between the glass and the wall. So, what sort of temperature are we getting for the windows?
13 or...
What was that? 13. Okay, and what sort of temperature are we getting for the walls? What was that? 10. So there's a 3-degree offset between the wall temperature and the window temperature. What about the geography building?
There's like 2 degrees difference.
2 degrees difference. Does everyone agree, or anyone getting other measurements? Now, why might there be a difference between these two buildings?
Age.
Age of the building, yeah.
The heating might be on, or that on lower temperature.
The windows are newer, I guess.
There's newer windows. What we have in the geography building is Pilkington K glass, double glazing, high insulation value. What we have in the biosciences tower is single glazing, old-fashioned glass, which has poor noise insulation qualities and poor thermal insulation qualities. So it's an older building, it hasn't had its glass replaced, it's going to have poorer thermal insulation. And if you've looked at the environmental indicator in the front of the geography building, you'll note that the geography building is pretty poor in terms of energy efficiency. It was built 15 years ago, so it's relatively new, but it's still pretty rubbish by modern terms. Biosciences, even worse. So what we're going to do is just, in terms of your measurements, I want you to write down the highest temperature that you can record from the nearest building. So we're at location 1, pick whichever building is nearest and locate the highest temperature that's coming out of that building.
Can we count biosciences with the windows open? Because there was a lot more temperature coming out there.
Well, there you go. That's an important point, isn't it? When if you miss that, the biosciences windows being open, you obviously get a much higher temperature reading coming out of that. And this is one of the classic things with older buildings, is because they're thermally inefficient, the heating comes on, it gets too hot, so people open the windows to cool it down, rather than being able to turn the temperature down on the heating systems. Newer buildings are much more smart in the way that the temperature is adjusted to be comfortable. And in a geography building, it's usually just really cold. Okay, so we can turn the thermal imaging cameras off for a second now. We've played with those. What's your next indicator? Pollution. Now, if we had a sensor, we could then get a reading on things like nitrous oxide pollution, CO2 and so on. We don't have those sensors today, but you can stand here and get one reading. What would the reading be like up at the road?
Worse.
Much worse. Even though we don't have a lot of traffic going by, the closer you are to roads, and it offsets very quickly as you come back from roads, you have much higher concentrations of those kind of classic pollutants. What does that say, knowing that, in terms of when you are walking along a road taking measurements of pollution, and then you create a temperature gradient surface of pollution? So if you've just walked along the roads, would your model be accurate for here? Why not? Anybody want to have a guess why the model wouldn't be accurate? If we're only measuring along roads, and here we are not on a road, why would our model, our calculation of what the pollution level would be here, why would it be wrong? Cars emit pollution, so we have much higher levels along here, along the road, much lower levels here, but if we're only measuring along roads, we're going to get much higher spikes of things. If you wouldn't mind, that'd be brilliant, thank you. Our pollution sensors are coming. So let's talk about some of the other indicators. So that's why models can be wrong. Models always have to be treated with caution. It depends where and how you're measuring. It's all right. I think we should probably be apologising for you for being in the way. Okay, so what's our next indicator? Smell. So, on a scale of 1 to 5, where 1 is neutral or pleasant, and 5 is really rank and unpleasant, what's our smell rating here? Let's hear a number. 2. Now, here I am, I'm sitting here and I'm saying, yeah, I'd say it's a 1 or a 2.
Yeah, man. Yes,
We're definitely into the 3s though. Okay, so this is a serious thing. If you are doing a measurement of something like smell, what things can affect your rating of that? Your own odour, the people standing around you. So if you're in a group doing a group survey, this can be shaped by the fact if one or other of your colleagues is particularly nice or particularly unpleasant smelling. So when you're doing a kind of smell test, you probably want to be stood away from the people you're going around with. However, what if you are at a bus stop? Now the people at the bus stop may or may not have a strong smell, but they are part of that environment, are they not? So you probably do want to stand next to them, and that's part of the thing which is creating smells that you're going to measure and record. Now, we said somewhere between 1 and 2. Is that an objective scientific measure? No, it's highly impressionistic. Does it matter, however? If we walked onto campus every day and it smelled strongly of sewage, serious question, would you come to campus less if every day you came knowing it was going to really smell grotesque here?
Yeah. You would spend less time.
You come here less. So if you are thinking about regenerating a neighbourhood, if there is something in that neighbourhood which smells particularly unpleasant, how likely are you as a developer to say, this is a place where I want to do a new urban development? Less likely. So smell matters. Even though we aren't necessarily going to do a scientific measure of smell, we can get a pretty good impressionistic measure of smell by just walking around and sniffing. I have a particularly messed up sense of smell, so I'm not as good as other people, but that's by the by. Okay, so smells. What's the next one?
Fear of crime.
Fear of crime. Well, now, we can measure fear. Hey, John. We can measure fear with science. So, who wants to have a go at measuring fear with science? Volunteer? Somebody can volunteer, otherwise I'll pick on someone. It won't even necessarily be someone that you expect I'm going to pick on. Now, are you feeling particularly frightened today? Okay, now, we have some sensors here. This is what we used to call a galvanic skin response sensor. They've got a different name now, but you see, we've got 2 little strap-on things which go on your fingers, and on your left hand, these 2 fingers. Right, so these go here and here. We need to go at the top of the finger, and the metal pad has to go in the back joint, so you need to tighten up the Velcro. Now, this being the modern world, we have smartphone apps for things. Are we strapped in? Okay, so this is how frightened she is. which is not massively scared right now. Now, if we were to get everyone to start shouting abuse, fear might go up. The problem with these measures... oh, we had a little spike then. We had a little spike. The problem with these kinds of measures is that they differ quite strongly between different people. So when I put that on, I might get a slightly lower reading, not necessarily because I'm more or less scared than you, but because my body works in slightly different ways. It's a good measure of fear if we're standing in a group. Because?
Reduce fear.
Yeah. Would you wear this walking around on your own? You'd feel a bit weird about it. So, thank you very much. You can go back now. You're out of the danger zone. So, actually doing a kind of scientific measure of fear isn't always necessarily helpful because it doesn't allow you to do something flexible. You're a star, thank you very much. Because it measures what you're feeling at that moment. It measures your bodily response at that moment, which means that it can be skewed by other environmental factors. If you're in a space like this, you can use your imagination. So, you can say, would I feel safe here at night? Now, if you're wearing the skin response sensor, it's not going to tell you that. You'd actually have to be there at night on your own to know that. But you can do a qualitative measure where you have your understanding of what your perception of fear would be. So it's a perception of fear rather than a scientific measure of stress, which is what the galvanic skin response sensor looks at. So we can do that kind of qual measure. So, standing right here in zone 1 on our map, from 1, perfectly safe, to 5, I believe I'm about to die, how safe do you feel? Okay. How safe do you feel if it's midnight? Well, the boys have said 1. What about the ladies? 2? 3. What about walking through underneath the university centre in that alleyway into the quad? Now?
Same.
At night? 3, 4. It's dark, you're on your own, you can't escape because it's quite narrow. It's not overlooked by things. How safe do you feel? So it's going to vary between people, it's going to vary between time of day, it's going to vary between genders, it's going to vary by age. Older people are going to be more fearful, generally speaking. Ironically, older people are less vulnerable to attack. Similarly, actually, in terms of violence in the street, men are much more likely to get attacked, but women are much more likely to be victims of sexual attack and much more likely to change their behaviours, believing that they're less able to cope with any attack that happens, whereas most blokes say, oh, I can take care of myself, even though clearly that's nonsense. Okay, so our fear of crime recording for where we are now. Write it down. It's your fear of crime. It's not what the consistency of the group is. Your fear of crime rating in this zone. Since the pollution measuring kit has just turned up, let's have a little go with that. So, these are relatively straightforward, apparently. There's an on button, and then it gives us a reading, hopefully. So, we switch them on. It takes a little moment to boot up. And we have some numbers. Okay? So this is giving us a scientific measure of air pollution. So what I would like is, we can't give one to each group because we've only got 3 of them. Now it's not going to be a problem tomorrow because I'm going to get you to swap around during the day, swap equipment around during the day. But for now, what I'm going to do is give one of these out to 3 of the 4 groups. So, And one group is just going to have to do without, but we'll let you have a play with that later on. Nice.
The vents at the back.
Yeah. So, as Dan was saying there, at the back you've got these air vents. Just keep those clear because that's where the air is being sucked in to do the measurement. Okay? So, write down a measurement for your group for where we are now. Okay, so we've done zone 1, and this was straightforward, was it not? I now want you to spend in your groups 40 minutes walking around campus. I want you to stop every 50 metres or so and take readings again, right on your map. You know, the number 2 for the next location you do, number 3 for the next location you do, and so on round. So you've got basically a series of points on the map where you've been taking the measurements and a table with the data in it.
Yeah, because we got like 2 numbers.
Yeah, you got 2 numbers. One is NOx and one is CO2, and I don't know which one's which, so pick the first number and just write it down, because in some ways it doesn't matter, because it's a relative measure. We know that here it's relatively unpolluted. We know that next to a busy road it's going to be more polluted. So that's all we need to worry about. Okay? So, are we clear on the activity? In your groups, one group is not going to have the measurement, the air pollution measurer. Walk around campus 40 minutes, taking measurements, creating a grid table of your measurements, and then meet back here in 40 minutes. So,
How many
points?
as many points as you do in that time. Okay. So, yeah, let's meet back here at past, actually. Meet back here at past.